All right, so here's our last one. And so we already know again the answers here. When we did it graphically, we said that it was going to be from -5 to -3. We had a bracket on 5 and a -5 on a parenthesis on -3. So now we're going to do it here. So again, the first step is to get everything to one side. So we're subtracting 2 from both sides. All right. Now, after we do that, step 2 says to go ahead and solve this out. So in other words, the only way to solve out a fraction and actual whole numbers, you have to get it to have a common denominator. So with this, it's understood to be 2 over 1. So here, we're going to do x plus 1. Sorry, let's do it in blue. X plus 1 over x plus 3. And we're going to multiply this other part here. Multiply it so they have the common denominator. So it means you have to multiply this by x plus 3. All right, we multiply everything through the numerators. So it'll give us 2x plus 6. And sorry, let's do the negative with it also. So -2 times x and -2 times 3. So we have x plus 1 over x plus 3 plus -2x minus 6 over x plus 3. Oh, sorry. At this point, we're supposed to be setting it equal to 0. Set equal to 0. So, okay. Move everything over, so now we set it equal to 0. Oh, no. I was right the first time. I kept it. We haven't started solving yet. All we did was actually get to this part. And you know what? This is all part of step 1. That's why it messed me up. Step 2 is when we actually set it equal to 0 and solve it out. But in this case, we're still in step 1. So sorry about that. It's not step 2, it's step 1. That's why I was kind of off a little bit. All right, so here we combine the two fractions so we get it down to one fraction. And then we can go ahead and solve it with step 2. Because in other words, the only way to solve it is if they have a common denominator. So if we combine this, we have one big fraction. Right. So when we do that, we'll have a -2x and a positive x, which is -x. We have 1 and a -6 is -5, all over x plus 3 is greater than or equal to 0. Right, cool. So we're there. So now step 2 says that we're going to solve this out. Now, the step 2 for a rational function is different than the step 2 when it comes to a polynomial function. What we're going to do here for rational functions only, we're going to set your denominator and numerator equal to 0. And this will give us our boundary points that we're looking for. Doesn't this sound so weird? I'm so calm and quiet. I'm not like this. I'm like loud and boisterous, like la 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 la. All right, this is where we set it equal to 0. So again, remember to take your numerator and denominator, set it equal to 0. So I'm going to do this off to the side over here. Let's do it in red. All right, so with that, we're going to solve it out. We get -x equals +5. And then we get x equals a -5 here. So we divide both sides by -1. All right, then here we get x equals -3. And so far we're doing good. We said that it was going to be between -5 and -3. So we have those two numbers for our boundaries. So step 3, we're going to go ahead and put that on the boundary line. All right, and we're going to try numbers on here so that we can kind of make sure that we have what we need. And again, we're going to go back to what we just did right there in step 2, and we're going to put the numbers into that. So we're going to try, let's say, -6 here, because we're going from -infinity to -5. And then from -3 to -4, we're going to try, sorry, -3 to -5 to -3, we're doing -4. And then from -3 to +infinity, and again, we're using parentheses right now. We'll come back and use brackets in a few minutes. We're going to use 0. We'll try 0. And again, we're going to go back to what we did in example in step 3 and actually substitute those values in there. And again, we're talking about where x is greater than. So x is greater than or equal to. So we're looking for answers that are positive here. If they're positive, then that means they're greater than, which means yes, that's what we need. All right, so for step 4, we're going to try it. I think, what did we say? -6? -6 into our function. So we have our function of -x minus 5 over x plus 3. Substitute -6 into it. All right, so that gives us a -11 over -3, which is a positive 11 over 3. Okay, so with that being said, that is a positive number. Oh, no, I did something wrong. Oh, I'm sorry, guys. I did something wrong because it shouldn't be positive. It should be a negative answer. I'm like, something's not right here. So it should be a negative that I left off right here. Sorry about that. So let's try that again. So that actually is a positive 6 minus 5 and -6 over plus 3. So here, that gives us a positive 1 up top and -3 on bottom. So it's a -1/3. Again, we're trying to find where it's actually greater than, not less than 0, greater than 0. So here, this is actually less than 0, and that's what we don't need. We don't need that. So that one's not going to be a part of it. All right, so let's go to the next one. Let's try -4. And so we're doing again -x minus 5 over x plus 3. I'm going to try -4 into it. So negative already. And then we have -4. Parentheses around that, minus 5. Then we have -4 plus 3 on the bottom. And we should have this work out. So that gives us a positive 4 minus 5 over -4 plus 3. So that's -1 over -1, which is positive 1. Yay! So that means it's positive, and that's what we need. So we get f of x is greater than 0. That's what we need. So far that's good, and that kind of that matches what we said already with when we did this graphically. And now let's go and do the last part, which we said we're going to try 0. Try Jesus, don't try me. Again, this is our function. So we're going to put 0 there. Doesn't matter if it's negative or not, because it's not going to change anything. We have 0 plus 3. So that will still give us a -5 over 3, which is negative. So that means f of x is less than 0. We don't need that part. So again, just like we said, it's going to be at x equals, it's going to be that second interval there. So step 5, we're going to go with that second interval from -5 to -3. Now with this again, this is where you have to remember where we're talking about our asymptotes and all that great stuff. Remember there's a vertical asymptote at -3. So with that, we can't use this portion here. We know that's a vertical asymptote, so it means it has to be parentheses right there, and at -5 we can use it. And again, remember, at x equals -3, there is a vertical asymptote. And so once you do a vertical asymptote, you know it's not equal there, so we have to have the parenthesis there. All right, and that's it. That's the whole thing. So we've done all of it. We've graphed them out. We've actually done it algebraically. And so now we're done.